There's an invisible shield protecting your most sensitive data, like right this second, and you probably don't even know it's there. So today, we're going to pull back the curtain on something called memory encryption.
So, look, you've probably done all the right things, right? You've got an encrypted hard drive, you use strong passwords, you keep your files locked. But what about the data you're actively using? I'm talking about the document you're editing right now, or that password you just typed in. Is that stuff really safe?
Okay, to really get why this memory encryption stuff is such a big deal, we first have to talk about a pretty surprising weak spot, a fundamental vulnerability really, in how our computers handle the data we're working with.
Most of us get the basic idea of encrypting our hard drive. It's pretty simple. When your computer's turned off, all your data is scrambled and safe. It's kind of like locking everything up in a super secure bank vault. And that's a great, essential first step.
So, let's stick with that analogy. Your hard drive, that's the vault. It's where your data is stored safely for the long haul. But here's the catch. To actually do anything with that data, to open a file or a picture, your computer has to take it out of the vault and put it on a temporary workbench. That workbench is your system's memory, what we call RAM. And the crazy thing is, for the longest time, everything on that workbench was just laid out in the open for anyone to see.
And that's the real problem right there. The second you open a file or log into a website, that information gets pulled from the vault, unscrambled, and laid out on that RAM workbench in plain, readable text. This creates this little window of opportunity, this moment of vulnerability that some really clever and nasty attacks are designed to take advantage of.
So, the big question is, how do we lock down that workbench? Well, the answer, fittingly enough, is the key itself: encryption.
When you boil it all down, encryption is a pretty simple concept. It's really just the process of taking your normal readable data and using a secret key to scramble it into a secret code. We call that ciphertext. And without that specific key, the code is totally useless. It's just a bunch of random gibberish.
And the process is super straightforward. You've got your plain data, like a password. You apply a unique secret key, and boom, you get scrambled data. And that's what keeps it safe from anyone trying to snoop.
Okay, but here's the real kicker. Your computer's memory, that workbench, is moving at an absolutely insane speed. So the challenge for engineers was massive. How in the world do you scramble and unscramble data millions, even billions of times a second without making your computer slow to a crawl?
And that brings us to the really cool modern solution. A technology that was designed from the ground up to be that invisible, super fast shield for your data, protecting it exactly when it's most at risk. What we're talking about is full system memory encryption. And the key is that it's built right into the computer's processor. It's not just software. Companies like AMD have really led the charge here with dedicated hardware technologies like AMD Memory Guard.
And yeah, I want to stress this. This isn't just some software you install. It's baked right into the hardware. So a technology like Memory Guard gives you this system-wide encryption by default. And the more advanced versions, they can protect against some pretty wild physical attacks. I'm talking about thieves literally freezing your memory chips to try and steal the data off them. This stuff helps stop that.
Okay, so this all sounds amazing in theory, but how does it actually work? Like, how does this invisible shield keep up with the lightning speed of your computer without you ever even noticing it's there?
All right, let's go back to that vault and workbench idea. With memory encryption, everything, and I mean everything, that gets moved from the vault to the workbench is automatically written in that unbreakable secret code. It's just never sitting there in plain text.
And the whole process is just seamless. Your computer needs some data. A special security engine encrypts it before it even hits that workbench. Then, it's decrypted just for the processor, for the split second it's needed, and then it's instantly scrambled again. This whole cycle just happens, over and over, billions of times a second, all on its own.
So what about performance? How much does all this crazy high-speed scrambling and unscrambling slow you down? The answer is pretty much zero. Nothing. Nada. That's because the whole thing is handled by a separate, dedicated security engine so it doesn't bog down your main processor. It's powerful security that is truly, completely invisible.
All right, so this is some seriously impressive tech. But let's bring it back to you. What does this invisible shield actually mean for you in your day-to-day life? Why is this a big deal?
Well, it protects pretty much everything you're doing on your computer at any given time. That password you just typed into your bank's website, protected. That super secret business document you have open, protected. Your private messages, all of it is scrambled and safe while it's sitting there on that memory workbench.
And this is a really big one. It's also about physical security. If someone actually steals your laptop, they can't just pop it open, yank out the memory sticks, and read whatever you are working on. To them, it's just garbage, completely unreadable, scrambled data.
So at the end of the day, real security isn't just about having a strong lock on the vault. It's about protecting your data when it's actually being used, out on that workbench, when it's most vulnerable. It's all about making sure that data is unreadable to literally everyone else but you.
Look, memory encryption is a huge step forward for our security. But you know, threats are always changing, always evolving. So it kind of leaves us with this big, important question. What's going to be the next invisible shield we need to protect our digital lives?